Hi everybody, welcome to today's video. We're going to be talking about functional groups today. It's a pretty common topic in Organic Chemistry 1 and 2, and it doesn't really go away. So we're going to start with the carbon-carbon bonds because I think those are just the most simple. So we'll just start with a carbon single bonded to a carbon. This is going to be your alkane. Note the ANE ending for a single carbon-carbon bond. Next is a carbon-carbon double bond. This is called a alkene, so this just changes the ending to ENE. And if you have a carbon-carbon triple bond, that would look like this, you will switch the ending to YNE, and this is called an alkyne. So I'm just going to draw what you might see these looking like in class, because on a test you're probably not going to see something quite this simple. So you'll probably see these long chains. These are called line structures, and this one would be considered an alkane. Professors might also call this a hydrocarbon chain, so don't be freaked out if you hear that. So an alkene would look something like adding a double bond, let's say in the middle. Now this part here would be an alkene. Now as far as naming goes, there are some rules that we're not going to get into today, so don't worry about that right now. Now if you had a triple bond, which would look something like this, this would be your alkyne. So it would be a YNE, like that. So you might see something that looks a little bit more like that, maybe on your homework or on a test. Okay, next we're going to be doing the nitrile group, N-I-T-R-I-L-E. So what's kind of nice about this is you see this kind of nite, kind of reminds you of nitrogen. So you got your nitrogen here. And this is just a C triple bonded to a nitrogen. Now this is the only nitrogen functional group that actually has this starter, kind of looks like nitrogen, so just kind of keep that in mind and try not to get them confused. So it might look something more like this. So at the end they will have C triple bond N, triple bond, there we go, N, or sometimes they might not, and they might just put CN. So just know that this part on the end here, and down here as well, these would be considered nitrile functional groups. So the next group that we're going to be looking at is the ketone. I think these come up quite a lot. What's nice is they do have kind of a shape to them. So you start with a carbon and you double bond it to an oxygen. Let me just write out ketone for you real quick so you can see how it's spelled. And then on the ends, like this, is usually going to be just carbon chains. Now here's the thing you might be seeing, is you might be seeing this letter R, and you might be going, well, what is that? R just means that anything can go there. So you could put a big chain, you could put one line. Generally it's going to be some type of big carbon chain, but it can continue into more complicated things that we're not going to be getting into right now. So I kind of think, okay, ketone, like if you really stretch your imagination, it does kind of look like a ketone. So it's kind of this group here. Yeah, I do think that at least my professor did test over those a lot, so I would just make sure those are pretty common. So next we're going to do another common one, which is called the ether. So this is another oxygen one. So it's just C bonded to an oxygen bonded to a carbon. And by C I mean carbon. So this one would look something like this in a chain, like with the line structure. Or you might see some big scary looking thing like this, and then your ether would just be this little guy over here on the end. You can kind of think like ether or like either carbon or carbon. That's kind of how I remembered it. I know it's a little bit of a stretch, but these do come up quite a lot, so I would definitely try to learn this one. Okay, the next functional group we're going to look at is an aldehyde. These are really similar to ketones, but I'll show you why There we go. But I'll show you why they're different. So if you have your carbon and you double bond it to your oxygen, this looks a lot like a ketone, doesn't it? But actually, this will be on the end of your chain and it will be attached to a hydrogen. So it will look something like this. It will be on the very end. Oh, sorry, that should be a hydrogen. There we go. That should be a hydrogen. So this is our aldehyde group right over here. Next, we're going to be doing arenes, or aromatic compounds. These you probably have seen before and thought, oh, these look really gross and complicated. And while they are a little bit more complicated, right now we don't have to worry about that. Right now we just have to worry about what they look like. So they're these rings. You might see these called benzene, so don't freak out if this is called benzene. Or arene, like this. Or aromatic compound. I don't know if your professors are going to go much more in detail, but the book that I'm using right now is just keeping it simple as arenes, looking like this. So look for the cyclic ring and look for those double bonds that are alternating. Next, we're going to be doing carboxylic acid. This again has that same carbon double bonded to an oxygen. Very familiar. Where this differs though is that we do put on the end a alcohol group. So this guy right here is called an alcohol group. And the whole thing together is called a carboxylic acid. So this can be abbreviated as Ca. That might be what your professor does. But let me try to spell out carboxylic for you guys. Carboxylic. Oop. We're gonna get close. Yeah, I think that's it. Carboxylic acid. This is gonna come up a lot when you get into acid-base chemistry or when you need to do oxidation and reduction. So this is a very big one. I would learn this one pretty high up on the list too. Next, we're going to be looking at esters. These are super common. So we have our carbon, our double bond to an oxygen, and then it starts off looking like a ketone again, but what we do is we add an oxygen group right here. Here, let me draw that a little better for you. Right here. So now we have an oxygen next to our ketone. So now this is a different functional group because of this. So it's called an ester. And again, just for consistency, R groups. Anything can go there. And let me go back a little bit to drawing just what these would look like. Might look something like that. And see, this can just go on forever. It doesn't matter. Alright, next group. The next group we're going to be looking at is just the alcohols, like I just mentioned. These ones are pretty easy. They're not too crazy. It's just a carbon bonded to an OH. That is it. So these can come in a variety of, I guess, how they look. You can get them in the middle of the chain. You can get them on the end of the chain. We're not going to get super into the difference between primary and secondary today. Just focus on that this is an alcohol. I mean, this one's not too bad because it even has OH OH like in it, so hopefully that one is not too hard to remember. Next we're going to do epoxides. These do come up a little bit later when you start doing like addition reactions. So these are actually a triangle. They look pretty weird. This is probably my least favorite one. I hate to say it, but I've never really liked these very much. So these are just kind of R groups on the ends, so don't worry about these. Focus on the central triangle with the carbon and oxygen. So this is an epoxide. And again, these won't come up for a little while. Usually they come up a little bit later, like more towards the end of the semester. Next we're going to do the two nitrogen functional groups that we haven't covered yet. So if we have C bonded to an N, but then that N has other substituents, which are just other lines and bonds, like this. This is not a nitrile, so do not say that. This is an amine. So this part here, and you can say this part too if you really want to, but technically it's just this part. I would include the ends just because it helps you remember, okay, there can't be a triple bond between the carbon and the oxygen here. So it's a single bond, so it's just an amine. These come up, but they're not quite as common as things like ketones, nitriles, aldehydes. But it all depends on your professor, so I'd still learn them. And then the other group is an amide. These ones are tricky. They're pretty big groups, so we have a carbon double bonded to an oxygen, and then instead of an O down here, we're going to do an N, so nitrogen like that. Here we have an R group, and then these can be R groups as well, so really focus on this part here. That's going to be your amide. I'm sure that you have supplementary textbooks or something to go along with this, but I do hope that this video maybe helped you just to have someone to kind of walk through it with you. There are a couple more that I'm not going to be drawing today just because they really don't come up a lot, but if you want or your professor recommends, always do what your professor says. I would look into the acetals and the phenol groups. I'm trying to see if there's any other ones that I didn't cover today. There's also groups called alkyl halides, but again, these are not going to be nearly as common, and I do think just by glancing at these, you'll be okay on your own. So, yeah, thanks for watching, and good luck studying. See ya!